All right, guys. So we'll move on with exercise 4D, right? So we were discussing about the intersection and union of sets. Okay. So discussing the answer for part D. So in part D, how does it work? How does the basically how does the intersection? I think you can see that we have kind of like shaded the region that is common to all the three. Can you guys see? So you can see this circle A, B, and C, and this shaded region is the region that is common to all the three circles, right? So in that case, there is not much of an effort for part D, right? Because part D is quite easy because it's in union you take everything, right? All the regions are included whatever you write. Okay. In intersection you only write the common region. So if you can see here, so circle A, B, C, this middle part, this middle region is the only region that's common. So this is basically A intersection B intersection C, right? Okay, because that's the region common to all the three circles. Agreed? That's the answer for part D. Okay, so we'll try the answer for part E as well. Okay, so in part E, you can see they have shaded all the three circles. Can you see? So it's fully shaded. No region is excluded. So all the regions inside all the circles are included. Circle A completely, circle B completely, and circle C completely. Which means, so this is not an intersection because intersection is the common region, but this is a union, right? So you can write A union B union C. In that case, you shade all the regions belonging to circle A, circle B, and circle C. And that's exactly what has happened. Okay. All right. So give an attempt on part F. So how does part F work? So you'll have to think a little bit here. So guys, in part F, if you look at it, I think you can see now you have part of circle A colored, right? And you have part of circle B colored, but who is definitely not colored? You can see definitely circle C is definitely out, right? Can you guys see? Circle C is definitely out. Circle C is not in this. Okay, so you can see if you take this previous example, so A union B union C is the whole thing, but now you have completely removed circle C. Can you guys see? Circle C is completely removed. So what you need to do here is, how do you do this? So it has A or B, but not C, right? A is okay. I mean, like, you take the A, you take B, but you remove the C part. But you should remove the C part. So how does it work? So how do you describe? So the shaded region is anything in A, or it can even be in B, but not inside C. Is that clear? It can be in A or B, but not inside C. So therefore, how do you write this? A or B, but not C. Right? So how does that work? So A or B means I have told you or is a union. A or B, but not C. So you need to remove C. Now don't, so if you're removing C, you don't take in the union, you should take intersection with C dash. A union B. Okay, so it's, you should take it separate like this. Let me show you. A union B. Okay, so A union B includes everything in circle A and B, but then you should take the common thing with C dash. C dash means you completely you don't take C. Okay, so you can check on this. So how do I check on this? For example, you can name regions, A, B, C, D, if you want, just do this. This is also an easy way. Okay. So what you need to do here is, okay, first you can get the answer for A union. So in circle A, what are the regions belonging inside circle A? So inside circle A, can you see there are 4 regions, simple A, B, C, and D. Can you see? Simple A, B, C, D belong to circle A, capital A. And then go to circle capital B. And then go to circle capital B. What are the regions belonging to circle capital B? What are the regions belonging to circle capital B? You can say B, C, F, and G, right? B, C, F, and G. Okay, so I'm just showing you a way to shade now. So then union. When you take union, how does it work? Union means you take everyone. Okay, union means take everyone. So A union B means it includes all these regions. Okay, so you get the answer here A. So write everyone that belongs here. So A is there, I wrote B is there twice, so don't include it twice. C is there twice, don't write it twice. D is there, F and G. So these are the regions coming for A union B. Are you guys with me? Okay, so you're supposed to take this answer intersection with C dash. Okay, what do you mean by C dash? C dash means the regions outside. C dash means the regions outside of circle C. So what are the regions outside of circle C? So I'm drawing the circle C inside like this. Can you see the green color line? So I am shading circle C. So everything inside circle C comes in this line. Okay, everything inside circle C comes like this. But what about the parts outside? I mean, C dash means outside, right? So outside the green color circle, who is outside the green color circle? You can see region A is outside, region B is outside. Can you see? Region G and region H. So A, B, G, H are the four regions belonging to C dash. Can you see? So C dash, you have A, B, G, and H. Do you guys see this? This is C dash. Anything outside, everything outside of circle C is C dash. Okay, and now take the intersection. Intersection means what? Intersection means you take the common region. So what is common to both of them? What's common to both of them? You can see for this A is common. What else? B is common. What else? G is common, right? A, B, and G are common. Can you guys see? A, B, G. So C, D, F, they're not common. So A, B, and G are the answering regions for this. So is that what we have done? Is that correct? So let me remove all the other shading. Okay, let me just remove all of this. I name this again. Let me write it again. A, B, C, D, E, F, G, H, right? This is the way I name. Can you see? So A, B, and G are the shaded regions. Can you guys see? I have got it correctly. See? A, B, and G are the shaded regions, which is exactly what I have over here. Can you guys see? So you don't need to write it like this, but you need to be able to think it out strategically. Okay. So this is how you, when the shaded region is given, this is how you write the answer. This I just showed you how to double check the answer. Okay, just in a manual way, but you can do it from your head. Okay. Okay, guys. So next I'll move on to question number 3. So they're asking you to shade A intersection B union C. So basically what I'll do here is first I'll name the region because that's a lot easier for us to work with E, F, G, H. Okay, you don't need, this is not compulsory. And if you can immediately see the shading region, go for it. Okay, but in an event, you know, some of the questions are tricky. So I'm just showing you a technique that when you get to shade using this technique, you can shade any region. Okay, so no matter how difficult this can be shaded. Okay, so look how it's done. A intersection B union C. Okay, so how does it work? So first solve the first part of the bracket. A intersection B. So what are the regions belonging to circle A? So what are the regions belonging to circle A? You can see we get simple A, B, C, D. Are the regions belonging to circle A? So write that down. A, B, C, and D. And then intersection B. So go to circle B. What are the regions belonging to circle B? You can see B, C, F, G. Can you see? That's B, C, F, and G. And then you're supposed to take the intersection. So what's the intersection? Intersection means the not the common thing. Okay, intersection is like the common thing. So A is sorry, A is not common. B is common. C is common, right? Yeah. So B and C are the only regions that are common. Agreed? So that's A intersection B answer. That answer, you're supposed to take that answer union with C. So C means what? Take the entire circle C. Okay, so C means take the circle C. Okay, so inside circle C. So you can get the region C, D, E, F. Can you see? Inside circles capital C, we have the region simple C, D, E, F. So write that down, C, D, E, and F. Okay, and now you're supposed to take what? It's supposed to be the union. Can you guys see? So when it comes to the union of these two guys, I told you union means take everyone. You don't leave anyone out. Okay, so whatever you have on the left side, the regions, whatever you have on the right side, you take everything. So, but don't repeat the same regions again. So you can see B is there, okay. C is there in both the cases. So write C once and then D, E, F. That's it. These are the regions that you need to shade. B, C, D, E, F. So you go to the question. So region B, C, D, E, and F. Can you guys see? So this is the answer for this. This is the shaded region. A intersection B union C. So this is the region that you need to shade for third question, part A. Okay. We'll move on to part B now. All right, guys. So moving to part B, A dash union B dash intersection with C. Okay. So work one thing at a time. First, we'll work with A dash union B dash intersection C. So how does that work? So A dash means the region outside of it, right? A dash means not inside. Remember, A dash means the A complement. So outside of it. So outside of it, we have E, F, G, H. Agreed? So I have over here E, F, G, H. Okay, and then B dash. So B dash means outside of circle B. So outside of circle B, what are the regions we have? Outside of circle B, I have A, D, E, and H. A, D, E, and H. Is that okay? So we have A, D, E, H. Okay. So basically, so this is the A dash and this is the B dash. Are you with me? Because B dash means outside circle B. A, D, E, and H. Okay. And now what you should do is, okay, first remember I'm solving this bracket. So I'm supposed to take the union of them. So guys, how do we take the union? Union means take everything. Union means take everyone. So what's everyone here? So you have here region, starting from the beginning, we have A. Okay, then I have A, B, C, D, E. Okay, D. Sorry, there's D here. Okay, there's E here. E is there twice. So write it only once. Okay, if it's there twice, write it only once because union just needs to include everyone. E, then F, G, and H, right? G, sorry, E, F, G, and H. H is there in both the cases. Okay, so I have written everyone. Can you see A, D, E, F, G, H? Yeah, so everyone's written. This is A dash union B dash. Are you with me? Okay, so this is A dash union B dash. Now this answer, I need to take it the intersection of this answer with circle C. So circle C is this guy. Can you guys see? The circle C is this C, D, E, F. Can you see? Circle C is C, D, E, F. So you write here C, D, E, and F. Okay, so now take the intersection. So now take the intersection. So what's the intersection? So what's the intersection? Intersection means take the regions that are common. Intersection means take the regions that are common. So which regions are common? A doesn't work. Okay, D is common. Okay, E looks common and F looks common. Yeah, so D, E, and F are the three common regions because now we are taking the intersection between these two sets. So intersection means the common region. So D, E, and F, and these are your answers. So which means what? In the diagram, you will shade the regions D, E, and F. So go to the diagram and shade D, E, and F. Can you guys see? So make sure you give the shading properly. So this is the answer. Okay. So this is what you need to shade. Okay. So we'll go for the next one. All right. So guys, we'll move on to part C. You're supposed to shade A intersection B intersection C dash. And then after that, you take the dash of the whole thing. Okay. So first, let's do the first part. A intersection B intersection C dash. Okay. We'll get this answer first. Okay. So basically, you have to get the region common to A, common to B, and common to C dash. Because they are giving you three sets, and all three sets, you have to take the regions common to A, B, and C dash. Okay. So let's do that. Okay, so what are the regions in circle A? In circle A, you have A, B, C, D. Okay, so you have A, B, C, and D. And then circle B, you have the regions B, C, F, and G. Can you see? In circle B, the regions are B, C, F, and G. So write that down. B, C, F, G. And then C dash. C dash means outside. C dash is outside. Outside means, the outside part. I mean, C dash means outside circle. So A, B, G, and H. A, B, G, and H. Can you see outside of circle C? And now you are supposed to take the intersection. Intersection means take the intersection of all of these. Are you with me? Take the intersection of all of these. So what's the common region belonging to all the three? Okay, so I can see A is common to A and C dash, but not for this one. Okay, so what's common to everyone? I can see B is common. Simple B. Is there in all the three, right? Is there anyone else who is there in all the three? C, no. D, no. G, H, no. So B is the only answer, right? Can you see? So the only person who is common to A, B, and C dash is region simple B. So that's it. That's the answer for A intersection, B intersection, C dash. But that's not what we're supposed to find. We're supposed to find A intersection, B intersection, C dash, the dash of that. The dash of that, which means what? The complement of that. The complement of that means now this is A intersection, B intersection, C complement. So I have to take the complement of that. So complement of that means don't take that region. Don't take that region. So everything except B. Everything except B is gonna be shaded. Are you with me? So B complement means you have region A, B doesn't count, C, D, E, F, G, and H. So this is the answer. This is the region you need to shade. Can you guys see A, B, C, A, C, D, E, F, G, H? There is no B. Okay, so basically you will shade everything except circle, except region B. So be very careful, be cautious. Is that clear? Okay. All right. So guys, we'll go to question number 5. A and B are two events. Probability of A is 0.5, probability of B is 0.2, and probability of A intersection B is 0.1. So guys, when we come to probability, I just want to give you a quick reminder. So you should remember certain things when it comes to probability. What are they? The first thing when it comes to probability, total probability always adds up to 1. Do you recall that? Total probability must be adding up to 1. It never exceeds 1. Total probability is always 1. So basically they are giving you two events and they have given the probabilities of each event. The probability that A happens is 0.5, the probability that B happens is 0.2, and the probability of A intersection B is 0.1. All right, so let's mark it. Now, if I talk about, let me mark the regions A, B, C, and D. So you can see there are only 4 regions. So when I say probability of A is 0.5, can I just mark 0.5 inside this circle? So I'm going to mark the probabilities inside the circle. So is it correct if I mark 0.5 inside the inside just this region? No, guys, that's completely wrong. Why is it wrong? Because when they say probability of A is 0.5, A means this entire circle. This entire circle is what they mean by A. So you take both the regions A and B. So A, B both should add up to 0.5. Are you with me? A, B both should add up to 0.5. Okay, so A plus B both should add up to 0.5. Another way of writing this is you mark the probability on top of the circle. Can you guys see? When you mark the value on top of the circle, it means that value is in effect for the whole circle, the complete circle. Okay. And when they say probability of B is 0.2, B means this entire circle. Can you guys see? B means this complete circle. So that is 0.2, which means I can mark it at the top. Are you guys with me? Which means this simple B plus C is 0.2. Okay, you don't need to write these extra things. Okay, I'm just writing it down to show you. Okay, but you can do this from your head. These are quite simple sums to be honest. Okay. And the last one, and probability A intersection B is 0.1. So what's A intersection B? At this point, we know what's A intersection B, right? A intersection B means the region that's common to circle A and the region that's common to circle B. So what's common to both circles A and B? The part that's common to both circles A and B is this region simple B. Can you guys see? So that is 0.1. So mark that probability as 0.1. Agreed? All right. So now what you can do is you can now find the individual probabilities of all the regions. Okay, let's find that. So if this simple B region is 0.1, you can find the value of simple A region. How do we do that? We know the total probability is 0.5. So you subtract 0.1 and you can see this part is 0.4. Can you see? So 0.4 plus 0.1 adds up to 0.5. Agreed? The other circle. Go to circle capital B. So you can see in there the total probability is 0.2. I have 0.1 here, which means region C should be 0.2 minus 0.1. Is another 0.1. Agreed? And then I told you the rule, total probability of all the 4 regions. You know, there are 4 regions here. The total probability must add up to 1. It must always add up to 1. So region A is 0.4, region B is 0.1, region C is 0.1 plus D equals 1. So 4, 5, 6. 0.6 plus D equals 1. D equals 1 minus 0.6, which is D is 0.4. Can you guys see? So D is 0.4. So I have now the probabilities of all the individual regions. I have the probabilities of all the individual regions. Oh, all right. So let's find the answer. Probability A union B. So guys, at this point, you know how to find A union B, right? So the circle A. The circle A, in circle A, what are the regions we work with? In circle A, we work with the regions A and B. Can you guys see? In circle B, we work with the regions B and C. So A union, now this is a union, which means you take everyone. So everyone means you take region A, you take region B, you take region C. So if you want to find the probability of A union B, now this is not about shading. Don't go to shade. You're not supposed to shade. They're asking you to calculate the probability. So to get the probability of A union B, you have to add the probabilities belonging to the individual regions, simple A, simple B, and simple C. Are you with me? So in simple A, what's the probability? 0.4. In simple B, what's the probability? 0.1. In simple C, what's the probability? 0.1. Can you guys see? Because this is the answer for this particular region. These are the, for A union B, these are the 3 possible, the regions that come for A union. So you will add the individual probabilities of these regions to get this answer. So how much is it? 4560.6. So this is the answer. Is this clear? So we'll try to do the other questions as well. Let's try the other parts. All right. So moving on to part B, probability of B dash. So guys, how do you get the probability of B dash? How do you get the probability of B dash? B dash means you don't include B, right? So removing circle B, what are the parts you have other than circle B? So inside circle B, you have the regions B and C. Outside, you have A and D. So B dash means regions A and D. So basically, add those the probabilities of those 2 regions. Probability of A is 0.4. Probability of D is also 0.4. Answer is 0.8. That's correct. Okay, so part C. Probability A intersection B dash. Probability A intersection B dash. So guys, what are the regions belonging to circle A? Inside circle A, I have the regions simple A and simple B. B dash means outside circle A. B dash means A and D. So intersection you have A, B, intersection means the common part, right? So what's common? Not union. Intersection is take only the region that's common. So you can see region simple A is common. So which means the answer is 0.4 because we only have one region. So directly the answer is 0.4. Agree? All right. Then part B, A union B dash. Part B, probability A union B and dash of that. Okay. So what are the regions coming for circle A? Circle A, you have regions A and B, right? Circle B dash means outside. So it's A and D, right? Now in this case, they want you to do the union. So how do you get the union? So union means you take the regions that are, you take everyone. So A comes, B comes, and D comes. A, B, D, everything comes. Can you see? So in A, the region is 0.4, B is 0.1, and D. So D is 0.4. Is that okay? Okay, so that's going to be 0.9. So answer is 0.9. Okay, so I hope this part is clear with everyone. Okay. Okay, guys, I'm moving on to question number 9. So you can see, moving on to question number 9, I have just given some reminders here, okay, because you need to remember these rules in order to do this question. Okay, so I have given you the rules regarding independent events and mutually exclusive events. So if two events are independent, if two events x and y are independent, then probability x intersection y is equal to probability of x times probability of y. And if x and y are mutually exclusive events, basically it means that there is no intersection between the two sets. Okay, so if they are mutually exclusive, it's a different story. It's like this. But if they are independent, it's a different story. Independent events can have an intersection. Definitely, there is an intersection, right? The intersection is equal to the product of the individual probabilities. Okay. All right. So now let's move on to the question. You need to have this theory in your head properly in order to do. They say A, B, and C are three events with probability A equals 0.55, probability B equals 0.35, and probability C equals 0.4. Probability A intersection C is equal to 0.2. Okay, given that A and B are mutually exclusive. Guys, can you see? A and B are mutually exclusive, and B and C are independent. So they have given you some things to consider here. Okay, A and B are mutually exclusive means when you are now, if you think of the Venn diagram, the circle A and B don't intersect. There is no intersection at all. A and B don't intersect. B and C are independent. So independent means there is an intersection because there should be an intersection. So if you think of the circle, let me draw this. Okay, so if you try to think of the circle, I mean the diagram, because part A they're asking you to draw the Venn diagram. The first thing is to figure this out. The first thing I understand is circle A and B do not meet. Okay, circle A and B don't meet. Okay, so make sure you draw circle A and B in a way that they don't meet. So this is circle A, this is set A, and this is set B. They do not intersect because they are mutually exclusive. A and B are mutually exclusive. This is what it means. B and C are independent. Okay, so B and C are independent means circle C will have an intersection with circle B. But what about circle C and circle A now? They don't tell A and C are independent, but also they don't say A and C are mutually exclusive, right? Which means what? When you're drawing circle C needs to have an intersection with both because they don't tell anything about A and C. So you can't just disregard that A and C don't intersect. No, A and C also has an intersection. Can you guys see what I'm doing over here? So the middle circle here, this is the set C. Okay, just that C and B are independent. Okay, so C and B are independent. A and C has no such thing. A and C are not. They don't say anything like that. So basically, this is what your Venn diagram needs to look like. Okay, so this is how your initial Venn diagram should look like. Okay, so now mark all the regions and you can, after you have a kind of like a layout of the Venn diagram, you can mark all the information. So I'll name regions A, B, C, D, E, and F. Okay. So probability A equal 0.55. Probability A equal 0.55 means the probability at the top. This is 0.55. All right. So this is 0.55. So because it's the full circle you need to consider. Okay, and then the next one, probability B 0.35, which means the entire circle B is 0.35. So mark it at the top of the circle because it's the whole thing. Probability C is 0.4. So probability C means the entire circle C. So probability C is 0.4. Okay, and A intersection C. So A intersection C is the middle, basically what's in between A and C, right? So A intersection C is the intersection of circle A and C. I hope you guys can understand. A intersection C is region B. So region B probability is 0.2. Can you guys understand that? That's really important. A intersection C is 0.2. All right. Okay, so then okay, so let's mark the other information. Okay, so basically we have marked the basic information. Okay, so now we have drawn the Venn diagram. We have marked the basic information. So you are supposed to, when they ask you to draw the Venn diagram, you need to, get all these probabilities. Okay, so let's get all the probabilities. Okay, how can I get the probability of region A? I think we can find the answer for region A easily, right? All right. So, how do you get region A? You can see the total of the circle is 0.55. So, 0.55 minus 0.2, that gives region A, that's 0.35. All right, guys. Okay. So, now the next thing here is we need to use the fact that the circles, the sets B and C are independent. So, if B and C are independent, since B and C are independent, what's going on here? Probability of B intersection C should be equal to probability B times probability C. So this is the rule. So you need to use this rule because that will give you the intersection of the circles B and C. Okay. So probability B is known. As you can see, probability of circle B is 0.35 times probability of circle C is 0.4. We know the full probability. So multiply 0.35 into 0.4. So get the answer. All right, so the answer is 0.14, right? So this answer, so basically B intersection C. You guys need to be able to see B intersection C, right? So where do circles B and C intersect? So you don't need to always, color. Okay, you can immediately see this. So the intersection means the region common to both circle B and C. I think you can all clearly see that it is this part, right? So this is the part that's common to both B and C. Can you see? Okay, so this is 0.14. Okay, region B is 0.14. Okay, so now we can easily calculate the value of region C and region E. Okay, so we can easily calculate that. So C and E. So region C, you can see the total. Okay, B plus C plus D. Because circle C is this whole thing. B plus C plus D is equal to 0.4, right? So B is 0.2. C is unknown, D is 0.14. Can you guys see? So the total of these three regions should add up to 0.4. So this can easily help you to find the value of C. Let's get the C value from 0.4. You should subtract 0.2 and you should subtract 0.14. Get the answer for region C. How much is that? All right. So region C is 0.06. Okay, so find that and you can mark that. That can be marked. Okay, now you can find region E easily because D plus E adds up to 0.35. Can you see? Circle D plus E adds up to 0.35. Can you see these two regions? So D is 0.14 plus E. Guys, I hope you guys can understand. What I did was I considered circle B here. So circle B has two regions, E and E. Add them together, it gives 0.35. So E is equal to 0.35 minus 0.14. How much is that? Get the answer. 0.21. Okay. So this is 0.21. Guys, can you see how you fill the Venn diagram? This is extremely important that you understand and you are capable of doing a sum of this capacity. Okay. So this is just the basic part where you need to read the question and from all the information given, you need to be able to identify the individual probabilities of all the regions. That's very important. Okay, you can see I have found the individual probabilities of regions A, B, C, D, E. There's one more region remaining, region F. So when it comes to probability, you know the rule, total probability must add up to 1. So A plus B plus C plus D plus E plus F, all of this should add up to 1. So guys, you don't need, really need to write all of this, okay? You can directly, subtract, take all these individual probabilities and subtract it from 1. There is absolutely no need to write all these, okay? A is 0.35. So guys, I'll do a shortcut here. B plus C plus D is circle C, if you guys can see. B, C, D is circle C. So instead of writing individual probability, shall I just write 0.4? Because I know B plus C plus D is 0.4. Saves our time if you want. Write the individual probabilities, that's perfectly fine. So E is 0.21 plus F equals 1. Can you guys see what I did over here? A is 0.35, B plus C plus D is this part. So that is the total is 0.4 plus E is 0.21 plus F equal 1. And now you can find the value of F. So f equals 1 minus 0.35 minus 0.4 minus 0.21. Yeah, so get the answer for region F. 0.04. Yeah, so it should be 0.04. All right, so I have the individual probabilities of all the regions now. So make sure you mark everything. So this is the complete Venn diagram. This is the complete Venn diagram. All right. Okay, so all right, so draw a Venn diagram to illustrate the probability. That's done. Find the probability of A dash intersection B dash. So guys, let's do this. Probability of A dash intersection B dash, B part 1. Probability A dash intersection B dash. Okay, so you need to find the regions corresponding to A dash intersection B dash. So guys, A dash means take the region outside of circle A. That's the meaning of A dash, right? So outside of circle A, what are the regions? You have C, D, E, F. That's A dash outside. Okay, so C, D, E, F. B dash is outside circle B. Outside circle B, the regions are A, B, C, and F. Okay, so intersection of both of them. Intersection means a common thing. So what's common to both of them? We can see region C is common. Okay, C is common, D is not common. Okay, E is not there, F is common. So we have A dash intersection B dash. So we have the region C and region F as common region. Are you guys with me? So all you need to do is to add the probabilities corresponding to region C and region F. So region C are probability 0.06, region F probability 0.04. You add it together, the answer is 0.1. Okay. All right, and then the next part. A union B intersection C dash. Okay, so let me take a copy of this diagram. All right, so B part 2, probability A union B intersection C dash. Okay, so over here, first you need to find the correct region corresponding to A union with B intersection C dash. Okay, so I think first we'll get the answer for B intersection C dash. Okay, and then take the union with A. Okay, so what are the regions belonging to circle B? So this is circle B. Regions belonging to circle B are D and E. C dash. So C dash means outside of circle C. So what are the regions outside circle C? You have A, E, and F. Right? So outside of circle C, C dash is A, E, F. Are you with me? So you're supposed to take the intersection. So what is the intersection? So intersection is the common thing. So I think we can see currently C dash is A, E, F. And then we take the intersection. So we have here a region E is common, right? Region E is common. All right, so then, so this is the answer for B intersection C dash. Okay, B intersection C dash is the answer. So this, we need to take the union with A. So we need to take the union of this with A. So what are the regions corresponding to A? So for circle capital A, we have simple A and B. So take the union. So union means take everyone, right? Union means you take everyone. So you have region A, B, and E. You have regions A, B, and E, right? So add the probabilities of those regions because that's the answer for A union B intersection C dash. So region A is 0.35. Region B is 0.2. Region E is 0.21. Okay, so add them all together. And what do you get? You get 0.76, right? You get 0.76. All right. Okay. Similarly, let's do part 3 as well. Okay, guys, moving on to Roman number 3. Probability A intersection C holding dash union B dash. All right. So first, let's get A intersection C and then take the dash of that. Okay. So when it comes to circle A, we have the regions A and B. Okay. So we have the regions A and B. And when it comes to circle C, we have the regions B, C, D. Right? Circle C has the regions B, C, D. So intersection of that is B. Okay, so that's B. Because that's the only region that corresponds. But the thing is, it's not just A intersection C. It's A intersection C. Whole thing dash. Dash means what? Don't take B. Dash means B. I mean, the complement of this particular set means without taking that particular region, take everyone else, like everyone else. So basically over here, you'll be taking other than B, you have region A. So you don't take B. Then you have C, D, E, and F. Guys, can you see? So this is the answer for A intersection C whole thing dash. A intersection C region corresponded to simple B. So when you take the dash of that, you take all the regions except simple B. Okay, so other than simple B, I took A, C, D, E, F. Great. So that is A intersection C holding dash. So now I have to take the union of that with B dash. So guys, what's B dash? B dash means take everything except, take everything except B or take everything outside B. B complement. Take everything outside B. So this is circle B, that's D and E. So other than D and E, take the regions outside except the ones inside D and E. So except the ones inside this, you take everyone A, B, C, and F. Agreed? A, B, C, F. All right, guys. So take the union. Take the union. So take the regions. It needs to union means take the regions that belong to both. Okay. So region A is there. Okay. A I have marked, and then we have B. It doesn't need to be common. You remember, union doesn't need to be common. As long as it's in one of the sets, it comes to the final answer because it's a union. Then C is there in both the sets. So we write C1, and then we have B here. And then we have E, and we have F. So F is there in both. Okay, so we write it once. So this is the union of the two sets, A, B, C, D, E, F. Guys, if you have A, B, C, D, E, F, everything, what does it mean? It means you have the complete Venn diagram. The complete Venn diagram means you don't even need to, add everything. You can understand it's just one. Okay, so this is the answer. So probability, this is equal to 1 because you have all the 6 regions. You have all the 6 regions. So total of all the 6 regions must add up to 1. Okay. All right. So I'll move on to question number 11. Members of a school book club reads either mysteries, that's M, graphic novel G, or epic fiction E. Probability M is 0.5, probability G 0.4, probability E is 0.6. Given that no one reads both graphic novels and epic fiction, and that probability M intersection G is 0.3, draw a Venn diagram to illustrate this probability. So guys, there's one important thing here. Given that no one reads both graphic novels and fiction, epic fiction. So basically, what does that automatically tell us? It tells us because there's no one who reads both of these books. It means these two sets are mutually exclusive. Okay, so they do not have an intersection. So when you draw the Venn diagram, okay, so when you draw the Venn diagram, you need to make sure the graphic novel, that is set G, and fiction is F, right? So those two sets need to be mutually exclusive. There should not be an intersection in between in those two sets. Okay, so when you draw the diagram, as you can see, so I have here okay, so you have this is, let's say, the graphic novels. Okay, and then epic fiction is over here. So make sure I need to make sure there's no intersection. Okay, so this is the epic fiction and then mystery. So mystery, they don't say anything that it doesn't intersect or there's no such thing. So you will have to draw that circle to intersect with both of them. Okay, so this is the mysteries. All right, so I'll mark my regions A, B, C, D, E, and F to make things easier for us. And then let's mark all the probabilities. Okay, so probability of mysteries is 0.5. That should come at the top of the circle M. And probability G is 0.4. So this should come at the top of this circle. And probability E is 0.6. What is E? Epic friction. Okay, friction is E, right? Okay, sorry, I need to name this as E. Okay, so the circle name is E. Okay, so it's E. All right, so they've named it as E. Okay, right, the circle name is E and probability E is 0.6. So that comes at the top of this circle. All right, given that no one reads graphic novels and epic fiction, and that probability M intersection G is 0.3. Guys, M intersection G, where is that? This is circle M, this is circle G. Where do the two circles intersect? This is M, this is G. Clearly, you can see the two circles intersect only at D. Can you guys see? These two circles intersect at this point. Okay, I'm not going to draw regions and do because it's pretty obvious, right? That's 0.3, this region. All right, so if that is 0.3, I think you can see we can find the other regions easily. How do I find that? This one, A is 0.4 minus 0.3, so region A is 0.1. Okay. All right, so I have, I think I have this section, right? So this is 0.1. All right. Okay, so how do I find the remaining probabilities? Okay, so how do we find the remaining probabilities? Okay, so what we'll do here is let's go for the next part of the sum. I think that's all we can mark at this point, right? This is 0.5, 0.4, 0.6. No one reads, so I have separated them. G and E, okay, and that M intersection G is 0.3. That's done. Okay. Okay, so we'll leave it at this point and let's go for the next part. Okay, what do they say? Guys, so over here, there's one more thing you need to do before you actually find this, right? Because you can see now these regions are unknown. But if you check on this, you can see region F. Now they say members of a school book club read either mysteries, graphic novels, or epic fiction. So which means everyone in the book club is reading one of these three because that's what they are in the book club and everyone reads at least one of these. So they would read one of the three types of books, which automatically means there is no probability. There's no one outside. You won't find any member who doesn't read the book in the book society, in the book club, right? That's what they say. Everyone either reads mysteries or they read novels or they read epic fiction. So therefore, the probability outside to be to in region F is 0. Okay, so that's 0. That's important. All right, so now what I'm going to do here is I'm going to attempt to find the values of CDE. Okay, so look at this carefully, how I'm going to find these three regions. Okay, so this is going to involve a little bit of a trick. Okay, I'm going to find the region CDE before I attempt this. Okay, look at this. So what's the trick that I'm attempting? Now I know that the total probability of all the 6 regions must add up to 1, right? I know that the total probability of all 6 regions add up to 1.
Yes.
Okay, so what I'll be doing here is, okay, just look at this. Guys, so the trick that I'm using here is I'm going to attempt to find one of these guys. But you can see there are 3 unknowns. So when there are 3 unknowns, guys, I'll be using this trick. Can you see this? B plus C plus D, because you can see, I know that B, C, D, all 3 of them add up to 0.5, right? B, C, D, all 3 of them add up to 0.5. Can you see? Though I individually don't know the values of C and D, I know that all 3 should add up to 0.5. So I know the individual value of region A. Individual value of region A is 0.1. B, C, D all together adds up to 0.5. Guys, this is the trick because you can see though we individually don't know CD, we know the full addition of B, C, D. So that helps us to avoid going through these unknowns. Okay, plus E is unknown. We don't know the value of E. And F value, I know it's 0. We found that it's 0. So guys, can you see I'm actually getting the E value, the value of region E. So that can be easily found. 0.1 plus 0.5, that's 0.6. plus E equals 1, E equals 1 minus 0.6, that's 0.4. So can you see the way I found the region E? So region E is 0.4. So these are some tricks that you need to learn. Okay, now I have the value of region E. Getting C and D is quite easy now, right? So I can first find the value of region D. So region D, you can immediately see here that D and E adds up to 0.6 because the circle E adds up to 0.6, DE adds up to 0.6, which means D is 0.2. Agreed? And now you can find the value of C because we know B plus C plus D is 0.5. Okay. So B plus C plus D is equal to 0.5. So B is 0.3. C is unknown. D is 0.2 equals to 0.5. Can you guys see? 0.3 plus 0.2 is 0.5. So C equals 0.5 minus 0.5. C is 0. Can you guys see? C is 0. Okay, so this is the complete Venn diagram. This is the complete Venn diagram. So this is important. First you have to draw this diagram and then you have to attempt the question. Okay, so we'll move on to the question. All right, so B part 1, you're supposed to find the probability. I'll write it over here. B part 1, find the probability of M union G. So guys, what are the regions belonging to M? M means this, right? So B, C, D. Can you guys see? Regions belonging to M are B, C, D. So B, C, D, union G. So guys, G is this. So G, inside G, you have regions A and B. So it's a union, means take everything. So you have A, B, C, D. Can you guys see? Union means take everything that belongs to both the sets. So region A, you have a probability 0.1. Region B, you have a probability 0.3. Region C, you have probability 0. Region D, you have probability 0.2. So when you add everything, 3, 4, 5, 6, 0.6. The answer is 0.6. Okay, and then Roman number 2, you have to find the probability M intersection G union with M intersection E. Okay, so guys, over here there's some work to do. First, you need to get the intersection of M and G. Okay, so what's the intersection of M and G? So we just found M regions are B, C, D. We found it up here. Can you see? Region G, you have inside G, you have regions A and B. You're supposed to take the intersection now. Okay, you're supposed to take the intersection. So how does the intersection work? You take the common region. What's common to both A, B, B, C, D and A, B? B is common. So B is common. Okay, so then you have to take the union of that with M intersection E. Guys, let's do that also. So inside M again, I don't need to write it, find again, B, C, D. And that common with E. Guys, what's inside E? Inside circle E, you have regions B and E. I hope you guys are following me. Take the intersection. So what's the intersection? So intersection means the common part. What's common with this? D. D is common. Can you guys see? So D is common. Okay, so B union D. Now basically at the end of the day, you're supposed to take the union of B and D. So union means you take both of them. Both regions B and D. Agreed? So region B answer is 0.3. Region D answer is 0.2. Answer 0.5. Okay, so this is the answer. This is, I hope this is clear with everyone. Okay. All right. So we'll move to the next part. We'll move to the next part. They're asking, are the events G dash and M independent? You must justify your answer. Okay, so are they independent, G dash and M? Okay, so this is part C. Okay, guys, so if two events are independent, you know the intersection of the events must be equal to the product of the individual probabilities. So they're asking, are the two events independent? So if G dash and M are independent, if they are independent, what's the requirement? Then the intersection of the two events must be equal to probability of G dash times probability of M. So this is the requirement. Okay. So let's see if this requirement is met or not. Okay, can you guys get me the probability of G dash intersection M? Guys, did we find it anywhere? G dash intersection M, did we find it? No, right? Okay, shall we find the probability G dash intersection M? So G dash means the regions outside of circle G. What are the regions outside of circle B? Inside circle you have AB. Outside you have C, D, E, F. Great. G dash is C, D, E, F. G dash, C, D, E, and F. Intersecting with circle M. Inside circle M you have the regions B, C, D. Can you see? Inside circle M you have the regions B, C, D. So take the intersection. What's the common thing? Intersection is take the common thing. So common we have region D. We have region C, right? C and D are common. That's it. So G dash intersection M is C and D. So guys, take the probabilities of C and D. C probability is 0, D probability is 0.2. So G dash intersection M answer is 0.2. You're with me? All right. So next, let's get the probability of G dash. So G dash means outside of circle G, right? I think I have the written here the regions. G dash means C, D, E, F. So because you are finding the individual probability of G dash, add the probabilities of the individual regions C, D, E, F. C probability is 0, D probability is 0.2, E probability 0.4, and F probability 0. Can you see C, D, E, F probability? So I added C, D, E, F probability. I get the answer 0.6. Okay. And then the next one, get the probability of M. What's the probability of M? Because I had to get these. I hope you guys are following me. I'm just getting these values here. Probability G dash I found. Now I'm going to find the probability of M. Probability of M we already have, right? The value of probability is the full circle. Probability of M is 0.5. I have marked at the top of the circle. Probability of M is 0.5. Okay, guys, now let's go to the independent test. Check whether the multiplication gives the correct answer. Probability G dash times probability of M. Probability G dash is 0.6 into probability of M is 0.5, right? So 0.6 into 0.5, that's 0.3, isn't it? That's 0.3. Can you guys see? So are the two events, are these two guys equal? G dash intersection M and probability G dash times probability of M, are they equal to each other? They are not, right? G dash intersection M is 0.2. This is 0.3. They're not equal. They're not equal, which means what? Therefore, you can say the events are not independent. So this is extremely important. Okay, you need to be able to understand and do sums of this manner. Okay, so deciding whether the events are independent or not needs to be clearly understood. Okay, so I hope all of you understood until this point.